Hello everyone. The purpose of this video is to go through the entire chapter 3 review. So feel free to skip ahead in this video to whichever question it is or questions that you need help with. I'm just going to go through all of them in order. So question number 1 says an experiment has outcomes O1, O2, O3. If O1 is twice as likely as O2 and O3 is 3 times as likely as O2, find the probability of O1. All right, so first thing that we should do here is remember that total probability adds up to 1. So if we have these 3 possible outcomes, O1, O2, and O3, then the sum of those probabilities needs to sum to 1. And then it also says that O1, let's put this one over here, that O1 equals twice as likely as O2, and O3 is 3 times as likely as O2. All right, so what we have here are 3 unknown values, and we were given 3 relationships where we were able to make 3 equations. So this is a system of 3 equations. So what I'm going to do here is use some substitution in order to solve. So instead of in this equation writing O1, I know that O1 is the same as 2 times O2 plus O2 plus O3 is 3 times O2. So the reason why this one was set up for substitution was because when I plug those values in, I get one equation in terms of one of my variables. So now I have 2, 1, and 3. So 2 plus 1 plus 3, that's going to give me 6 O2 is equal to 1. So divide both sides by 6. And I know the probability of whatever outcome 2 is going to be 1/6. And now that I know that the probability of that is 1/6, I can plug this back in. So this is going to be 2 times 1/6, which would give me 2/6. And if I want to reduce that down, that would be 1/3. And that means that O3, outcome 3, is 3 times O2, so that would be 3 times 1/6. So that would be 3/6, which is 1/2. All right, so let me just double check. 1/6 plus 2/6 plus 3/6 is 1. So those would be my 3 possibilities of my outcomes. All right, question number 2, a Venn diagram would probably be a good idea here. It tells us that we have a sample space, that we have events E and F, and it gives us the probability of E and it gives us the probability F as well as the intersection. And then we have to find these other values. So a Venn diagram would probably be a good idea to get our information kind of visualized, sorted out. So we have E, we have event F, and I know that I'm supposed to draw these as overlap. These are not mutually exclusive because it tells me the probability of E and F is 0.2. Had it said that these 2 events were mutually exclusive, I would have drawn these 2 circles so they did not overlap, which meant that there wouldn't be the probability of E and F would be equal to 0. If it tells you that they're independent, it could be mutually exclusive, or you could draw them like this. You just have to use that independence formula, which we'll probably use sometime later in this. So anyway, I drew it overlapping because the probability of the overlap is 0.2. So starting with the innermost, I have 0.2. The probability of E is 0.3. So all of this circle adds up to 0.3. 0.2 has already been established for being in the intersection. So this is going to be 0.3 minus 0.2, which means that this is going to be 0.1. F, the probability of it is 0.6. Again, 0.2 has already been established, so that's going to be 0.6 minus 0.2, which is going to give me 0.4. Remember that the universal set, the sample space, the probability of that has to add up to be 1. So if we know what these are, then that means outside of these events is going to be 1 minus 0.1 minus 0.2 minus 0.4. This all sums to 0.7, which means on the outside we're going to have 0.3. So now we answer our questions based off of everything that we have established over here. So the probability of not E, well, E is in the circle. So not E is what's going to be on the outside of it. It's either in F or it is outside of F. 0.4 and 0.3 together would make 0.7. And again, the reason why I'm adding those is it's either going to be an F or it's going to be outside, not in both, or remember we means add. The probability of E or F, so that means it could be in any of these three locations, the union, that's going to be 0.1 plus 0.2 plus 0.4, which is going to also be 0.7. The probability of E and not F, so that means that it has to be in circle E, but not in F. So what's in circle E but not in F? That's this portion out here, which would be 0.1. And then the last one is not in E and not in F. So not in E would be anything outside of circle E. Not in F would be anything outside of circle F. But the and means it has to be where they both are. So this is asking for outside of all of the circles, which is going to be 0.3. All right, for this next one, again, I'm going to make a Venn diagram to help myself visualize it. And we have two events. We have event E and we have event F. Now I'll either draw those where they don't overlap or if they do. It doesn't say anything about mutually exclusive, and it also once again tells me that the intersection is 0.3. So because an intersection exists, that means I'm going to draw them so they intersect. It says that the intersection is 0.3, so I'm going to label that. But this time it gives me that the union is 0.8, so that means that all of everything inside the circles adds to 0.8. And this right here tells me the probability of not E. So let me label this as event E, and this one is event F. So not E is 0.4. All right, let's go ahead and start off with that one. It looks like we're going to probably need to write a little equation to figure this out. So not inside E is 0.4. So here's E. So outside of it is 0.4. There are two parts to that. So I'm going to call one of them X, and then the other one, I'm going to call it 0.4 minus X, because these two together need to add up to 0.4 because they are what's the complement of E. There's what outside of circle E. The other piece of information that we were given is that E or F is 0.8. Okay, so if I just labeled this portion as X and this portion is 0.3, this piece as well, with those three included, needs to add to 0.8. So this portion is going to be 0.8 minus 0.3 minus X. So 0.8 minus 0.3 would give me 0.5, and then minus X. All right, so what I was able to do was come up with an expression for each of the regions in this Venn diagram. And that means that I have a possible equation that I can write in the fact that all of these spaces, wherever they are located, all of those regions needs to add up to 1. Because the probability that something's going to occur is that 100%. So that's always going to be 1. So this is going to be everything that's inside of my circles, which I could use 0.5 minus X plus 0.3 plus X. I could add all those up, or I know that all of my circles add up to be 0.8. So I'm going to go ahead and do that. But again, if I add all of these up, that's going to give me 0.8. Plus what's outside the circles, which is plus 0.4 minus X, that needs to add to 1. So that's going to give me 1.2 is equal to, whoops, hold on a second. Sorry about that. It's going to give me 1.2 minus X is equal to 1. And so that is going to give me that, let's see, I'll move this over. That'll give me 0.2 is equal to positive X. All right, so then filling my values back in now that I know them. Now I know that X is 0.2, so this portion is 0.2. 0.5 minus X would give me, so 0.5 minus 0.2 would give me 0.3. And double check, yes, those all sum to 0.8. And then this piece on the outside, 0.4 minus 0.2, that's going to give me 0.2. All right, so now that I have my Venn diagram, now I can go back and answer these questions. So the probability of E Anything inside circle E together sums to 0.3 plus 0.3 is 0.6. The probability F would be 0.3 plus 0.2, which would give me 0.5. And then this one is conditional probability. What's the probability of E given F? All right, so if you need to, there's a formula for it, okay? And formulas will be provided on this test, since this test happens to be open book, open note. So look for that formula if you need it. That formula for conditional probability is the probability of E and F, so their overlap, their intersection, divided by the probability of F. So this would be equal to E and F is 0.3. Probability of F we just said is 0.5. So that's going to be 0.3 divided by 0.5, which is the same thing as 3 over 5. 3 over 5, which would be 0.6.